Our project aims to reduce ambient outdoor temperatures through both ventilation and shading. To only shade is not enough. The hot air and humidity needs to be channeled elsewhere as well. Firstly, we collected data at site and did sun exposure analysis to find out which area require more shade and/or ventilation. We then categorized our site into 4 parts: the southern corridor, the northern corridor, interior courtyards, and the drop-off point. We conducted experiments to find out the relationship between geometry and increase in wind speed for one module. The 3 parameters that we used are angle, size of exit, and size of entrance. We ensured that the amount of wind that enters the modules as well as the initial wind speed to be both constant. In the second phase, we then repeated this experiment with triangular modules to determine the effect of shape, and found out that the increase in wind speed for triangle is negligible. In our third phase, our parameter is materiality as it relates to shade. We tested out various materials and measured the range of opacity. After finding the most suitable module for each area on the micro scale, scaling up means putting the modules together on a macro scale. We did 3 levels of mapping. Firstly, differentiating materials. The longer each part is exposed to sun, the more opaque the material gets. Then, we varied the size of entrance. The longer each part is exposed to sun, the smaller the entrance. Lastly, the longer each part is exposed to sun, the smaller the exit hole. This is done parametrically using Grasshopper. We tested the effects of hexagon versus square on CFD and realized that hexagons increase wind speeds more than square. Hence, for our final facade, we decided to use hexagons instead of square.